Chapter 2 review sheet. Here's the assignment right here. Hopefully you have this copy down already and you know exactly what you're doing, okay? Let's jump into this right away. Let me grab my Algebra 2 book here and turn over to page 115. Excuse me. And let's get started. Here we go. Number 15. The directions say to find the slope of the line. We should go through these pretty quickly. In order to find the slope of a line when given 2 points, you use the formula y minus y over x minus x, okay? Here's your x, here's your y, here's your x, here's your y, okay? So, having said that, y minus y, you have negative 3 and 7 for your y's, so negative 3 minus 7. X minus x, for your x's you have 1 and 6, so 1 minus 6. Now students, if you put this y first here, then you must put this x first here. If you put this y first here, then you must put this x first here. Other than that, it does not matter what order you go in. Negative 3 and negative 7 is negative 10. 1, negative 6 is negative 5. Negative over a negative is positive. 10 over 5 is 2. So the slope of this line is positive 2. Number 16, the exact same thing again. So here we go. There's your formula. This time we're going to go the opposite direction. We're going to put this y first and this x first. So here's my x, my y, my x, my y. For my numerator, y minus y, so I have a 12 and a negative 3 for my y's, a 12 and a negative 3. So 12 minus a negative 3. For my x's, I have 0 and 5. 0 minus or 0 negative 5. Notice I put this 12 first, so I put this 0 first here. 12 minus a negative 3 is 12 plus 3, or 12 positive 3, that's 15. 0 negative 5 is negative 5. A positive divided by a negative is negative, and 15 over 5 is 3. So the answer is negative 3. Alright, okay, moving on to numbers 19 and 20. Let me go back and look here. Okay, 19 and 22 is double intercept method. 23 and 24, table of values method. Slope intercept is last, 25 and 26. So students, here we go. We're going to graph number 19 using the double intercept method. I'm going to put 0 in for x. And then I'm going to put 0 in for y. I do this to get the x-intercept and the y-intercept, okay? 2 times 0 is 0. 0 minus 5y is negative 5y. Divide both sides by negative 5 and y equals negative 4. There's the y-intercept. So now I know the line crosses the y-axis at negative 4. Over here, negative 5 times 0 is 0. 2x minus 0 is 2x. Divide both sides by 10, or by 2, excuse me, and x equals 10. So now I know the line crosses the x-axis at 10. Okay, so with that in mind, let's grab these two here. Let's pull them up here. And let's graph. Here we go. On the y-axis, we'll go to negative 4. 1, 2, 3, 4. On the x-axis, we'll go to positive 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go, and we graph the line. There we go, okay. Now on your test, I'm going to mix the equations in with the inequalities. These types of problems here are the ones that you have to shade. These you don't shade, okay? So having said that, we do not need to shade on this problem. Just graph the line and you're finished. Okay, moving on to number 20. Okay, we're going to use the double intercept method again. So where the y is right here, I'm going to substitute 0. And where the x is, I'm going to substitute 0 also. Right here. And now here we go. 9 times 0 is 0. 0 minus 12 is negative 12x equals 27. Divide both sides by 12. And the decimal answer, the fractional answer is going to be 2 and 1/9. Alright? Negative. But let's see, 27 divided by 12. The decimal is going to be, or 2. I said 2 and 1/9. 2 and 1/4 is what it would be. And that's what I get for trying to do it in my head. Negative 2 and 1/4. The decimal would be negative 2.25. Okay, there we go. Now let's find the y-intercept. I know the line is going to pass through the x-axis at negative 2.25. Now let's find out where the line is going to cross the y-axis at. 12 times 0 is 0. Negative 9y minus 0 is negative 9y. Divide both sides by negative 9. Excuse me. And y equals negative 3. So there are my axes, okay, if you will. My x and y intercepts. And so let's graph this line very simply and very quickly. All that I have to do is go to my x-axis at negative 2.25, so negative 1, negative 2, negative 3. So negative 2.25 is about right here. And then I need to go to the y-axis at negative 3. So 1, 2, 3. And now I'm good. Now I can graph my line. Remember, students, in order to graph a line, in order to graph a linear equation, all that you really need is 2 points. Okay, now you might say, Mr. Earhart, on the table of values method, you make us find 3 ordered pairs. I do, just to be safe than better safe than sorry, okay? But technically speaking, all that you need is 2 points to draw a line, okay? Alright, numbers 23 and 24, we're going to use the table of values method, okay? So, off to the side, I'm going to put my table of values. And remember, I like to use the numbers 0, 1, and 2. You're welcome to use the other numbers if you want, okay? So where x is, I'm going to put a 0. Where x is, I'm going to put 1. And where x is, I'm going to put 2. And now let's see what happens for each situation, okay? 0 minus y is negative y. If negative y equals 9, then y equals negative 9. Or another way to look at it is, there's a negative what right here? Negative 1. So divide both sides by negative 1. These cancel. 9 divided by negative 1 is negative 9. So when I put 0 in, I got out negative 9. That's an ordered pair. Now, let's go ahead and simplify this equation. I have 1 negative y equals 9. In order to solve for y, bring the positive 1 over and make it a negative 1. So now I have negative y equals 8. If negative y equals 8, then y equals negative 8. So I put in 1. I got out negative 8. Now look at your pattern here. The next number should be negative 7. Let's see if it is, okay? 2 minus y equals 9. So 2 negative y equals 9. Bring the 2 over and make it a negative 2. So negative y equals 7. If negative y equals 7, then y equals negative 7. There it is. So students, I just got 3 ordered pairs, did I not? Sure I did. All that I have to do now is graph those 3 ordered pairs, and I'm finished, okay? I'm going to draw my coordinate plane a little different here because I have to go all the way down to negative 9, so I'm going to draw it a little unbalanced here. So here's my y-axis, here's my x-axis. My first point is 0, negative 9. So, here's my first ordered pair right here, 0, negative 9. I go to 0, then down negative 9. My next ordered pair is 1, negative 8, right here. So I go over 1 and down negative 8. here's my next ordered pair. I go over 2 and then down -7 to right here. And there's my line. Just take a straight edge. The side of your calculator will work just fine for a straight edge usually. And there you go. Okay. All right, moving on to number 24. Same system. Well, I said same system. I mean same method. Here we go. Table of values. On the test, you're going to have to prove to me you know how to use all three methods, okay? It's very important you understand that. So where the x is, I'm going to substitute 0. And I'm going to substitute 1 for x. And then I'm going to substitute 2 for x. So look at that, students. Everywhere there's an x, here, here, and here, I substituted 0, 1, and 2. Alright, 2 times 0 is 0. 0 minus 10y is -10y. Divide both sides by a -10. And y equals a positive, for negative is negative. 15 divided by 10 would be 1.5, or 1.5. So negative 1.5. Now I substituted 1 in for x. So 2 times 1 right here. 2 times 1 is 2. -10y equals 15. Bring the 2 over and make it a -2. So now I'm left with -10y equals 13. Now divide both sides by -10. These cancel. Y equals a positive over negative is negative. 10 goes into 13 ones with how much left over? 3. So 1 and 3 tenths. Or if you want to type into your calculator 13 divided by 10 or divided by -10, you'll get -1.3. So to be honest with you, you look at this pattern, 1.5, 1.3, the next one should be 1.1. Let's see if it is, okay? Alright, 2 times 2 is 4, so I have 4, -10y equals 15. Cross the 4 off and bring it over here, it becomes negative, so -10y equals 11. Divide both sides by -10. These cancel. Y equals -1.1. 11 divided by 10 is 1.1. So it looks pretty good. I've got my 3 ordered pairs. Now when you try to graph these, they're going to be these 3 points are going to be grouped together pretty closely, pretty tightly, but it's no big deal. That's fine. We still get a pretty good idea of what the graph looks like, okay? And here we go. Zero, -1.5, that's my first ordered pair, so I go to 0, then down 1.5. My next ordered pair is 0, -1.3, 1, -1.3, so I go to 1, then -1, then 0.3 is a little closer. And then my next ordered pair is 2, -1.1, so 2, then -1.1. And it's not easy, guys, to line these up perfectly, but on a test or a quiz, when I see your table of values and see where you put your points, I can totally tell that you're trying to put them in the right place, okay? So there we go. So far we've reviewed the double intercept method for those two and the table of values method for these two. Now the next two, 25 and 26, are going to be the slope intercept method, okay? The slope intercept method. So here we go. Take really good notes. Whenever I ask you to graph a linear equation using the slope-intercept method, the first thing you must always do is isolate the y. That means get this y all by itself. Now sometimes that's already done for you. If it's already done for you, then just skip the problem, or don't skip the problem, okay? But skip that first step. So let's get y by itself. Bring the entire term over 2x and make it negative. So 8y equals 24 -2x. Now divide everything by 8. y by itself. These will cancel. Y equals 3. Positive divided by a positive is positive. Over here we have a negative divided by a positive, so the whole fraction becomes negative. 2 over 8 is 1/4 x. So there, I got y by itself. Pretty simple. Step 2 is to write out your slope and your y-intercept. For example, y is all by itself. What number is all by itself? Which number is the constant term? 3. So 3 is your y-intercept. Which number is right next to the x, right beside the x? Negative 1/4. That's going to be your slope. So far, step 1 is get y by itself. Step 2, write out your slope and y-intercept. And now we're ready to graph the equation. The next thing we do is we plot the y-intercept, okay? We plot the y-intercept. So the y-intercept is b is in boy, and the y-intercept is 3. So I go up 1, 2, 3, and I put a point right there. That's the y-intercept. Now if you'll think about it for a second, students, the rest of it really is just kind of common sense. I mean, in order to draw a line or graph a line, you need how many points? 2. Well, so far, I have how many points? 1. Well, if I know the slope of the line is 1/4, that means I have a rise of 1 and a run of 4. So from this point right here, I can rise 1 and run 4. So I'm going to go up 1. So from here, I'm going to go up 1, then over 4. 1, 2, 3, 4. So there we go. Notice, students, when I went up right here, I did not put a point there. A lot of students do that, and then they get confused as to which points they're supposed to connect. You do not put a point until you've done rise and run. So you rise 1, run 4, put a point. Oh, by the way, why did I go up? Because the 1 is positive. Why did I go to the right? Because the 4 is positive. What if one of them's negative? We'll talk about that in a second, okay? There we go. Alright, let's continue on to number 26. Okay, students, once again, we're going to graph a linear equation using the slope-intercept method. Step 1 is get y by itself. So if you want to get y completely by itself, the first thing you do is bring the negative 4x over. By the way, notice I don't bring the negative 4 over and then bring the x over. Okay? This is one term. When you move things in an equation, you must move complete terms. Okay? So bring the negative 4x over and make it a positive 4x. Okay? Now divide everything by 5. So divide by 5, divide by 5, divide by 5. This cancels and you're left with y equals 16 over 5 is 3 1/5. Or if you don't like that, that's the same thing as 3.2. A positive divided by a positive is a positive, and 4 over 5 is 4/5. And actually, students, on number 25 I made a mistake, did I not? That's really frustrating. I did. When I bring the 2x over, it becomes a negative 2x. Yeah, my fault, guys. And then we divide by 8, you get a negative 1/4 for the slope. Well, I mean, what can I say now? Well, on this line here, I hope some of you come back and watch this. Not a lot I can do about that now, but the slope was really a negative 1/4, and I apologize. So you put the negative sign up top, or you put it in the bottom. It does not matter, but don't put it in both. So the negative can go here, or the negative can go here. It really doesn't matter. I'm going to put it here, just because I feel like it. So we're going to say the 1's positive and the 4's negative. So if the 1 is positive, you rise 1. Now the 4 is negative, so you go to the left is positive, you go over 4. And look, the points, all 3 points still line up in a straight line. So you get the same line no matter what, it doesn't matter. Okay? And I really apologize about messing up number 25. When you bring the 2x over, it's negative. Then when you divide everything by 8, a negative divided by a positive is a negative 1/4. Okay? Alright, totally my fault. Back to number 26. So, a positive over a positive is positive. So here's my equation. So step 1 is to get y all by itself. Now step 2 is to then list out your y-intercept and your slope. So I'm going to list those out. And now the next step is to graph the linear equation. So I'm going to draw my coordinate plane here the best that I can with my limited drawing skills. And let's see what we got here. Alright, here we go. The y-intercept is 3.2. No, that's a positive 3.2, so I'm going to go up 3 and then approximately 0.2 about right here. Now, please listen to me carefully. You have a rise number of 4 and a run number of 5. When you go to rise 4, you do not go to here and then here and then here. You go up 1 whole segments. So if you're at 0.2 here, when you go up 1, you're at 0.2 here, 0.2, 0.2, you're going up 1 whole step. If I went from here to here, that wouldn't be a whole step. That would be 8/10 of a step. So here we go. I'm going to rise 4. So I start here and I go 1, 2, 3, 4. So I'm right here. Then I run 5 over, which would be about right here. And that's just an estimation. But 1, 2, 3, 4, then over 5. And there we go. There's my line. Okay? And then use a straight edge and connect those 2 points, and you should be good. Okay, students? So there we go. Make sure on your test you know how to graph make sure you know how to use 3 different methods of graphing linear equations. Alright, moving on to number 29 and 30. Numbers 29 and 30. The directions say to write an equation of the line that passes through the 2 given points. Okay? So we're going to write a linear equation. Now students, I gave you 2 different models to use when it comes to writing linear equations. The one model looked like this, and I told you to use this model when you're given 2 points, like we are here, or when you're given 1 point and the slope. Okay? The other model I gave you was this model here. And I told you to use this model here when you are given the y-intercept and the slope. Okay? But in this situation here, we are given 2 points. So here's the model I'm going to use. Now the problem with using this model is we don't know what the slope is. You see, in order to use this model, we have to know the slope. So we have to find the slope first. So we just did that earlier in the review sheet, so we'll do it really fast. Y minus y, that's 0 and 6. 0 minus 6. X minus x, that's 7 and 9. 7, negative 9. So I get a negative 6 over a negative 2, a negative over a negative is a positive. Positive 3. So now I know what my slope is. Now students, please listen to me. It does not matter after we know our slope. Okay, listen carefully, please. After we know our slope, it does not matter. I'm going to put the slope right up here. It doesn't matter which ordered pair you use to write your linear equation. Now on the next problem, number 30, I'm not gonna do it 2 different ways, but on this problem here, I'm going to use this ordered pair for this formula, this model, this ordered pair for this model, and you're going to see you got the exact same answer. Okay, so here we go. Y minus a y value. My y value is 0. My m value is 3. That's my slope. And then x minus an x value. My x value is 7. So x minus 7. Alright? So y minus 0 is just y. 3 times x is 3x. 3 times negative 7, negative 21. Booyah. Just like that. Finished. Okay? Now one thing you can't do is you cannot take an x value from here and a y value from over here. You pick one point or the other. So we picked this point right here. Now we're going to pick this point, and we're going to get out the exact same answer. Y minus a y value. My y value is 6, so y negative 6. My slope is 3. Then x minus an x value. My x value is 9, so x negative 9. Multiply your 3 through carefully. 3 times x is 3x. 3 times negative 9 is negative 27. Now, you're never finished writing a linear equation, at least not in my class, until you've isolated the y. So we're going to bring the negative 6 over and make it a positive 6. If we do that correctly, we're going to get y equals 3x negative 21. The exact same answer we got here. Okay? Number 30, they want us to write a linear equation. Right away, we noticed that we're given 2 points. So because we're given 2 points, we're going to use our model right here. This is the model you use when you're given 2 points or when you're given 1 point and the slope. Okay? So here we go. First, I must find the slope because I need the slope right here in my model. Y minus y, that's 5 minus 4. X minus x. My x's are 6 and negative 7, so 6 minus a negative 7. 5 negative 4 is 1. 6 minus a negative 7 is 6 plus 7, that's 13. So your slope is 1/13. Okay, now remember, your calculator can help you a lot with your fractions. Excuse me. So don't hesitate to use it, okay? Alright, pick an ordered pair. I'm going to pick this one because there's no negative numbers. So here we go. Y minus a y value, y minus 5. For m, I'm going to substitute 1/13. X minus an x value, my x value is 6, so x negative 6. Next I have y negative 5 equals 1/13 times x is 1/13 x. And then, if you're good with fractions, you know that a positive times a negative is negative. 1/13 times 6 over 1 is 6/13. However, if you struggle with that, then take your calculator. Type in, don't worry about the negative sign. You already know that a positive times a negative is negative, so put your negative sign. Then take 1/13 times 6 and hit enter. Now when you do that, you're going to get a decimal. You're going to get something that says 0.461538446, etc. Then hit math, enter, enter, and when you do, 6/13s will pop up here. Okay, easy enough. Now, next we're going to bring my negative 5 over and make it positive to get y all by itself. So once again, if you struggle with fractions, you'll want to use a calculator. If you don't, for me, I can see right away, I would have, 65, negative 6, positive 65. I'm doing this in my head, but I'm getting a negative 59 over 65. Now, I could be wrong. Let's check the answer real quick. And that's right, it'd be over 13, my fault. So, negative 59 over 13. And so a really good reason not to do it in your head, I'm just kidding, but use your calculators, okay? So if you want to use a calculator, here's what you do. You have a negative 6/13, so type in negative 6 divided by 13, then plus 5 or positive 5. And when you do that, your screen is going to say 4.5384661, etc., etc. Hit math, enter, enter, and it will say 59 over 13. Now, for some reason, mine is saying, let's see, positive, and it would be positive, that's correct. It would be positive. And there it is. Okay, so I tried to do it in my head. I failed, obviously, but if you're pretty good with fractions, you can do it in your head fine. If not, use your calculator. Okay, alright, moving on to numbers 37, 38, 39, and 40. We're going to do 41. We're going to do 5. 1, 2, 3, 4, you need to notice that we do not have an equal sign right here. We have an inequality. On your test, I'm going to mix all of those together. I'm going to mix your equations with your inequalities, with your absolute values. They're going to all be mixed together, so you must learn to look at a problem and figure out what type of equation or what type of inequality it is. This is an inequality that has one letter. Any inequality that has one variable is either going to be a horizontal line or a vertical line. Got it? Now, x is not by itself, so we're going to come over here. The first thing you always do, students, always, 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 I cannot stress this enough, is to off to the side, just pretend you have an equal sign, even though you don't right here. Pretend you have an equal sign. Now get x by itself. And we get x equals 3. See, some students like to get x by itself with the inequality. The problem with that is if you have a negative sign here, you forget to turn the arrow. Or what if you test your point? In this case, we're not going to test a point, but if your arrow is facing the wrong way, you're going to miss the problem. The best thing to do, students, I'm telling you, really, is to you want to get the x by itself, okay? And that's important to do, and we're going to do it with the inequality eventually. But the first thing we want to do is get the line drawn, okay? Let's get the line drawn. So x equals 3. So go to your x-axis at 1. This is my x-axis, this is my y-axis. Whenever you have just x in an inequality, it's going to be a vertical line. So I'm going to go to x equals 3 and put a vertical line. Now check to see if it's dotted or solid. In this case, it would be dotted. Now, just like we got x by itself over here, go ahead and get x by itself over here. Why do we have to do that? We have to know where to shade. X is less than 3. Got it? So if x is less than 3, x is less than 3, then we shade to the left over here. If it would have said x is greater than 3, then we would shade over here on the right side, okay? But it doesn't say that. X is less than 3. So there we go, guys. That's simple. Alright, number 30. I wish they had given you one with a negative sign. That would have been good practice for you to remember to turn the arrow. Okay, here we go. Let's go ahead and the first thing we're going to do is we realize we have an inequality, and then we have y all by we have an inequality with only a y value, no x value. So because of that, we know right away we're going to have a vertical or a horizontal line. Well, I'm going to rewrite it with an equal sign like I've taught you guys to do. Okay? Now I'm going to divide both sides by 4, and y equals 2.25. So very good. Now I know where to go on the y-axis. This is going to be a horizontal line. Here's my y-axis. Here's my x. Go to the y-axis at 2.25, so approximately right there. Okay? Now, next thing we're going to do is to get y all by itself so we can see which way to shade. So divide by 4, divide by 4. Y is greater than or equal to 2.25. So if y is greater than 2.25, well, by the way, the line that I'm going to draw here is going to be a solid line. And I know it's going to be a solid line because of the equal sign that's right here. Okay? Y is greater than this line, so I'm going to shade above the line. If it would have said y is less than, then I would shade below the line, okay? But it's not. So y is greater than or equal to 2.25, so I shade above the line. Now numbers 39, 40, and 41, those all have two variables, okay? So when I look at 39, I notice right away that I have two variables. So my line is not going to be horizontal. It's not going to be vertical. It's going to be slanted. Next, I notice obviously that I have an inequality. So I'm going to rewrite this with an equal sign. Now students, when I do that, I notice right away y is all by itself, correct? Sure it is. So if y is all by itself, then I know right away that the y-intercept is the constant term. And the slope is the number with the x. In this case 1, or 1 over 1, which is 1. So how fast can I graph this? How about super fast? I mean, this is so easy, guys. Learn to recognize fast shortcuts like this. Y is already by itself. So for B, my y-intercept intercept, I'm going to put a point at 5. 1, 2, 3, 4, 5 right here. And then I'm going to rise 1, and I'm going to run 1. So rise 1, run 1. Now why did I go up? It's a positive 1. Why did I go to the right? It's a positive 1. Do I draw a solid line or a dotted line? Well, there's an equal sign here, so I'm going to draw a solid line. Alright, there we go. Now students, the next thing we must do is we must test a point to see where to shade. You see, a lot of you on your test forgot to shade on your quizzes. On your quizzes we took earlier in this chapter, you forgot to shade on problems like these. That's going to really come back to haunt you on the test. You must remember to realize or remember your original problem had an inequality. Therefore, you must shade. So, I'm going to test a point. 0, 0 is my favorite point to test. Where the y is, I'm going to put a 0. Where the x is, I'm going to put a 0. 0 positive 5 is 5. This says 0 is greater than 5. That's false. So this point right here is false. So I'm going to shade where that point is not, which is up here. Moving on to number 40. Now number 40 has y by itself again. I'm going to do this one a little differently. Let's walk through this step by step by step. First of all, I see that I have an inequality with two variables, x and y. So I know my line or my boundary is not going to be horizontal, it's not going to be vertical, it's going to be slanted. Number 2, I'm going to rewrite it or pretend that I have an equal sign. Now because y is by itself on this problem, I'm going to very quickly just put numbers in for x. So I'm going to do this one a little differently just for the fun of it. I'm going to put in 0, 1, and 2. So if I put a 0 in for x, negative 0 is 0, 0 positive 4 is 4. So I put in the 0 I got out of 4. Now let's put a 1 in for x. Put a 1 in for x. There's a negative sign here. So I have a negative 1. A negative 1 positive 4 is positive 3. So I'm going to put a positive 3 here. Now look at this pattern. The next number should be 2. So I'm going to put a 2 in for x right here. There's a negative sign. So I put in a 2. Sorry about that. I'm not putting in a negative 2, putting in a positive 2. So I put in a 2. There's a negative sign here. Negative 2 positive 4 would be 2. So I get out of 2. So now very quickly, I can plot my 3 points, draw my line, and I'm pretty much home free except for the shading part. I cannot forget to shade. Alright, so here we go. Alright, 0, 4, over 1, up 3, over 2, up 2. There's my 3 ordered. There's my 3 ordered pairs right here. 1, 2, 3. Now notice there's no equal sign here, so it's going to be a dotted line. And my 3 points are not lining up perfectly, but that's because my graph is not perfect. So it's okay. There's my dotted line. Now what point do I love to test? Whenever I can. 0, 0. Never test a point that lies on the line. Never test a point that lies on the line that you graphed. And here we go. For y I'll substitute 0. For x I'll substitute 0. Negative 0 plus 4 is 4. 0 is less than 4. That's true. 0 is less than 4. So this point right here is true. So I'm going to shade where that point is. Alright? So there we go. Moving on to number 41. Okay, students, here we go. Let's graph this inequality right here. Okay, students, here we go. We're going to graph this inequality. The first thing you notice, hopefully, is you have 2 letters, or 2 variables, an x and y. So we know right away it's not going to be vertical, it's not going to be horizontal, it's going to be slanted. Next, we notice we have an inequality, so we are going to have to shade. Don't forget that, okay? Now, let's pretend that we have an equal sign here. Now let's find what I'm going to do, because I have an x and then a y and then an equal sign and then a constant term. What I'm going to do is I'm going to use the double intercept method. So where the x is, I'm going to substitute 0. And where the y is, I'm going to which form the equation's in. Like, watch how fast this is. 0 plus 8y is 8y. 8y equals 1 divided by 8. Y equals 1 8, so there's the y-intercept. 8 times 0 is 0. X plus 0 is x. X equals 1. So just like that, I have my two intercepts. Now granted, they're going to be really close together, but I can still get a good quality line if I use a straight edge. So on the y-axis, I'm going to go to 1 8. That's barely up, okay? Right to there. On the x-axis, I'm going to go to 1, which is right here. I do not have an equal sign here, so I'm going to use a dotted line, okay? So here's my dotted line, and again, it's not going to be perfect. It's not supposed to be perfect, but it's supposed to be neat and do the best you can, okay? Now, for me, I'm awful close to 0 0. I'm not going to test a point that's close to 0 0. So I'm going to test 2 2. I'm going to test this point right here, 2 comma 2, to see where I shade. Okay, now you can test any point you want that does not fall on the line. I'm choosing 2 comma 2 because I feel like it. Okay, so here's the x, I put a 2. Here's 8 and then a y, so 8 parentheses 2. Obviously it's going to be false, guys. Look, I mean 8 times 2 is 16. 16 plus 2 is 18. 18 is less than 1. That's false. 18 is not less than 1. 18 is greater than 1. So this point right here is false. So I'm going to shade where that point is not, which is down here. Okay? Alright, moving on. We're going to graph 1, 2, 3, 4. 4 absolute value inequalities. I want to make sure you guys understand how to do this. So if it's repetitive, but it's good practice for you, okay? Now remember, on your test, I'm going to mix all of these together. I'm going to mix the linear equations with the absolute value equations with the linear inequalities. You must learn to recognize each one. This is obviously an absolute value equation because you have an x inside the absolute value. Thus, you know you're going to get out a V-shaped graph, either opening up or opening down, okay? So the first thing you do, step 1, is find the vertex. You take the inside of the absolute value always and set it equal to 0 always. Then solve for x. Divide both sides by 3, x equals 0. So for your table of values, and you definitely want to draw a table of values, one that holds 5 ordered pairs. Right in the middle goes your vertex. So the x value is 0. The y value is always going to be this number here that's being added or subtracted. If this would have been a negative 5, then you put a negative 5 here. In this case, it's a positive 5, so we put a positive 5 here. So let's pause right there. Does everybody see how to find the vertex? The vertex is that point on the V of the graph right there. The point on the V. Now, let's review. I took the inside of the absolute values, set it equal to 0, and solved. That gave me the x value of my vertex. How do I find the y value? Well, whatever number is being added or subtracted to the absolute value, that's going to be your y value. Now, some of them don't have a number here. In that case, then you put a 0 right here, okay, if there's no number here. Alright, moving on. So, now because I have a 0 here, I'm going to go up to 1 and then 2, and then down to negative 1 and negative 2. So very quickly, you're welcome to enter these into your calculator and use your table of values there. I've taught you how to do that, and hopefully you know how to do that. It'll save you a lot of time. However, if you don't, that's fine also. You're welcome to do it the long way, which is to put 2 in for x. So I have a 2 right here. 3 times 2 is 6, so the absolute value of 6 plus 5. The absolute value of 6 is 6. 6 plus 5 is 11. Next, we're going to put in 1 for x. So let's go ahead and substitute 1 in for x right here. 3 times 1 is 3, so I have the absolute value of 3 and then positive 5. The absolute value of 3 is 3. 3 plus 5 is 8. Alright, now we're going to put negative 1 in for x. So here we go. 3 times negative 1. 3 times negative 1 is negative 3. So I have the absolute value of negative 3, positive 5. The absolute value of negative 3 is 3. And 3 positive 5 is 8. Alright. Next, I'm going to substitute in negative 2 for x. So right here for the x, a negative 2. 3 times negative 2 is negative 6. The absolute value of negative 6 is 6 positive 5. 6 positive 5, which is 11. Okay, so there we go. Looks like on my y-axis I'll be going all the way up to 11. So I'll draw my x-axis way down here and my y-axis way up here to give me a little bit more room here. Okay, your vertex is 0, 5 right here. 0, 5. Now one order pair is 2, 11, so over 2 and way up to here. And then your other order pair is 1, 8, so over 1, and then up 8. Then negative 1, 8, and then negative 2, 11. And there's your phi right there. There we go. Okay, so really not too bad, students. Find the vertex first, then write your table of values, and then sketch the graph. All right, number 44. We're going to take the inside of the absolute value, set it equal to 0, and solve. So here's my inside x equals 0. So that's it. No need to solve. X equals 0. So for my table of values, I'm going to substitute. I'm going to draw a table of values that holds 5 order pairs. Right in the middle, I'm going to put 0. And then next, for my y value for the vertex, I look at the numbers being added or subtracted. To the outside, it's going to be 3. So I put 3 right here. And then because I'm at 0, we'll go up 1, then 2. Then go down negative 1, negative 2. And here we go. Put a 2 in for x. The absolute value of 2 is 2. 2 plus 3 is 5. Put a 1 in for x. The absolute value of 1 is 1. 1 plus 3 is 4. Now put negative 1 in for x. The absolute value of negative 1 is positive 1. Positive 1 plus 3 is 4. Now put a negative 2 in for x. The absolute value of negative 2 is 2. 2 plus 3 is 5. So there we go. Vertex is 0, 3, so 0, 3. My order pair here is over 2, up 5. Then 1, 4, so over 1, up 4. And then negative 1, 4, so negative 1, up 4. And then negative 2, 5, so negative 2. And then up 5. And so there is your V-shaped graph, okay? Hard to draw there, but there we go. Okay? Alright, moving on to number 45. 45 and 46, still done the same way. And here we go. Alright, number 45. We do have an absolute value equation. So we're going to take the inside of the absolute value, and we're going to set it equal to 0 and solve to help us get the vertex. Bring the 4 over and make it a positive 4. So now I have the middle x value on my table of values. So I'm going to put a 4 right here. Okay, now what about the y value? We'll look at the number that's being added or subtracted to the absolute value. It's a positive 3, so put a 3 here. Now because you have a 4 here, we'll go up to 5 and 6, then down to 3 and 2. Alright? So let's put a 6 in for x. Put a 6 here. 6 minus 4 is 2. The absolute value of 2 is 2. 2 plus 3 is 5. Now let's put 5 in for x. Put a 5 right here. 5 minus 4 is 1. The absolute value of 1 is 1. 1 plus 3 or 1 positive 3 is 4. Now let's put a 3 in for x. Okay, pause the video there. Went to talk to one of my sons. I don't know if you guys could hear him or not, but they're playing some football game. And they're yelling and screaming, having a good time, so hopefully you guys could not hear them. Okay, I'm back. So we're going to put a 3 in for x right here, okay? So 3, negative 4 is negative 1. But the absolute value of negative 1 is positive 1. So positive 1, positive 3 is positive 4. Here's your vertex, so over 4 and up 3. There's your vertex. Now one ordered pair is 6, 5, so over 6 and up 2 more to 5. 5, 4 is an ordered pair over 5, up 4. 3, 4 is an ordered pair over 3, up 4. And then 2, 5 over 2 and up 5 right there. And so we have a really nice V-shaped graph. If I could ever actually hit the points, but anyways, you get the idea. So there's the V-shaped graph, the absolute value graph. Okay, moving on to number 46. Number 46. All right, here we go. So students, right away we realize we have an absolute value function, so we're going to find the vertex first. Take the inside of the absolute value, set it equal to 0 and solve. Bring the 7 over and make it a negative 7. And that value is going to go in the middle of your table of values, okay? There we go. Now, getting greater or higher or larger than negative 7 would be negative 6, negative 5. Getting smaller would be negative 8, negative 9. There we go. Now what about the y value of your vertex? Well, it's always the number you're adding or subtracting to the entire absolute value. So negative 12. Okay? So there we go. Now, let's go ahead and start substituting these x values in. We'll start with negative 6. If you put a negative 6 here, negative 6, positive 7 is 1. The absolute value of 1 is 1. 1 minus 12 or 1 negative 12 is negative 11. Now we'll put a negative 5 in. Negative 5 plus 7 is a positive 2. The absolute value of 2 is 2. Positive 2, negative 12 is negative 10. Alright. Now let's put in a negative 8. So we'll substitute negative 8 here for x. Negative 8, positive 7 is negative 1. The absolute value of negative 1 is positive 1. Positive 1 and negative 12 is negative 11. And then lastly, we'll put a negative 9 right here for x. So negative 9, positive 7 is negative 2. So the absolute value of negative 2 is positive 2. Positive 2, negative 12 is negative 10. So we're going to put a negative 10 here. Now students, look. Learn to draw coordinate planes that match your values. For example, for your x-axis, you're going to go from negative 5 to negative 9. For your y-axis, you're going to be way down the negatives. So why not draw your coordinate plane like this? I mean, it makes sense, doesn't it? I mean, you need the negative y x numbers and negative y numbers. So I'm just saying, learn to draw your coordinate plane using a little common sense, and that will end up saving you time later. Okay? Because you won't have to try to make more room or slide stuff around. Okay? Now, we're going for our vertex is negative 7, negative 12. So 1, 2, 3, 4, 5, 6, 7. So we're right here. Negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So right down here. Right there, there's the vertex right there. Okay? Now, one of my order pairs is negative 5, negative 10. So 1, 2, 3, 4, 5, negative 5. Then down 2, right here, it's negative 10. Another order pair is negative 6, negative 11. So, negative 6. Negative 6 would be right here. The negative 11 would be right about there. And then negative 8, negative 11. Negative 8, negative 11 is about right there. And then negative 9, negative 10 is about right there. And once again, you can see your V. Okay? So there we go, guys. Hopefully after these 4 examples, you feel pretty confident in graphing absolute value equations. Step 1, find the vertex. Step 2, fill in your table of values with 5 ordered pairs. Step 3, sketch the graph. Alright, moving on now to, I think, another page. Yes, we're moving on to page number. And I honestly don't have that in front of me. Let me quickly glance at the review sheet here. Page number. 74, then we'll go to 90, then page 111, so page 74. And the directions say for numbers 5, 6, 7, and 8, we're going to write a linear equation, okay? No, I'm sorry, we're going to find the slope, estimate the slope. Well, I taught you in your notes, the first day we went over slope was a horizontal line always, always, always has a slope of 0. That's simple enough. Jumping ahead to number 8 real quick. A vertical line always has a slope that is undefined. Undefined, undefined. Okay? Alright, moving backwards now to number 5 and number 6. In order to find the slope of this line, we need two ordered pairs. Now we're looking for a place where this blue line goes right through the crosshairs of the graph, okay? Somewhere like this. So, right here the blue line goes right through the crosshairs, and right here it does. So you highlight those 2 points, and then you draw a right triangle. You can go up and straight over and connect the 2 points like that, or you can go straight over and then straight up. Either way, it doesn't matter, okay? So, we're going to find the rise and the run. Start here for the rise and count up. 1, 2, 3, 4. Start here and count up. 1, 2, 3, 4. So my rise is 4. Now start here and count to the right. 1, 2. 1, 2. So I have a rise of 4, a run of 2. Rise over run is 2. Now is it going to be positive or negative? Well, here's the left side of the graph. Here's the right side. From left to right, is it going upward or downward? Upward. So that means your slope would be positive. So your answer would be positive 2. Number 7. Alright, we need to mark some places here where the graph goes right through the crosshairs. Looks like we're good right here and right here. Okay, so draw your right triangle. Okay, we're going to rise from here. Start here and count your rise. 1. Now start here and count your run. 1, 2, 3. Let's try it again. Start here. 1, 2, 3. So your rise is 1, your run is 3. So rise over run. Now is it going to be positive or is it going to be negative? Well, here's the left side of the line. Here's the right side. Going from left to right, is it going upward or downward? Well, obviously it's going downward. So your slope is going to be negative. A negative 1/3. Alright, moving on. We already did number 8 already. The answer is no slope. Okay, moving on now to page number 90. We're going to look at numbers 8 and 10 and 12 and 14. So here we go. Now for numbers 8 and 10, the directions say to write the equation of the line. Okay, write the equation of the line. Well, students, can I just tell you something? Anytime you're able to find the y-intercept, do so. Okay, it makes writing a linear equation so easy. And for 8, 10, 12, and 14, the directions say to write the linear equation or write the equation of the given line. So, right away I know my y-intercept. I see the line goes to the y-axis at -9. So right away I know my y-intercept is -9. Now let's find the slope very quickly. Here's a point. Here's a point. Now we can find the slope really quickly. Rise over run. Okay, the rise would be 1, 2, 3. The run would be 1. So the slope is rise over run, 3/1. Now going from the left side to the right side, the line is sloping downward, so your slope will be negative. So your slope is really -3. Now, why did you do that, Mr. Earhart? Because, guys, you cannot write the equation of a line unless you have 2 ordered pairs, or unless you have an ordered pair and a slope, or a y-intercept or something. So I quickly found the y-intercept and the slope. Now we're not going to use this model here. You use this model when you have 2 points or 1 point in the slope. This model here, however, is what you use when you have the slope and the y-intercept. And that's exactly what we have. The slope of the line is -3, and the y-intercept is -9. So whenever you're given the slope and the y-intercept, you use this model here. So y equals m, that's -3, and then x, and then you put your b, positive b, we have a -9. Please don't put positive -9. I will take off points for that. It's just -9. And there's your answer. Y equals -3x minus 9. Let's try another one. Number 10. Look, exact same thing, guys. They give us the y-intercept here. The line crosses the y-axis at 6. Let's find the slope now very quickly. I'm looking for where the blue line goes to crosshairs. Right here. Right there. So go over and go down. Rise over one, run. Your rise would be 1, 2, 3. Your run would be 1. So rise over run, 3 over 1, or just 3, but hold it. Some of you might see Mr. Earhart. I chose this point here and this one down here, no problem. Instead of getting 3 over 1, you're going to get 6 over 2, which is the exact same thing as 3. Here's your rise. Start here. 1, 2, 3, 4, 5, 6. Here's your run. Start here. 1, 2. So your rise is 6, your run is 2. 6 over 2 is 3. Exact same thing. Now going from the left to the right, we're going upward. It's going to be a positive slope. So do we have the y-intercept? Yes. Do we have the slope? Yes. Anytime I give you the y-intercept and the slope, here's the model you want to use. There it is. So y equals 3x plus, for b, we're going to put 6. Y equals 3x positive 6. Now 12 and 14 are even easier because they give you the y-intercept and the slope. You don't have to find them. Number 12. Nope, I stand corrected. I apologize, guys. On number 12, they're giving you a point and the slope. So anytime you're given a point and the slope, you use this formula or this model right here. So here we go. Let's get after it. Y minus a y value. My y value is 0. For m, I'm going to substitute 4. X minus an x value, which is 4. So x minus 4. X minus, or y minus 0 is y. 4 times x is 4x. 4 times -4 is -16. So there we go. Let's check it and see. There we go. You're never finished writing a linear equation, at least not in my class, until y is all by itself. Moving on to number 14, notice once again they give us a point and the slope. Anytime you're given the point and a slope and you're asked to write a linear equation, we're going to use y minus y1 equals x, or equals m. X minus x subscript 1, okay? So, y minus a y value, my y value is 7, y minus 7. My m is 2/3. X minus an x value, x minus 6. There we go. Now, take your 2/3 and multiply it through. 2/3 times x is 2/3 x. 2/3 times -6 would be -4. Once again, if you need to use your calculator, you would type in, well, you know that a positive times a negative is negative, so put your negative sign. Then in your calculator, type in 2/3 times 6. And when you do that, you will get out 4, okay? And of course, there's a negative sign here, so -4, all right? Okay, bring the 7 over and make it a positive 7, and we're finally finished. Y equals 2/3 x. Positive 3. And look at that. There's our linear equation, okay? Alright, moving on to our last problem finally. And here we go. This is a scatter plot. They want us to write a linear equation that models this information. Now, we did this in your homework already about a week ago or so, but I needed one for you to practice, so we're going to do a problem that we've done before. Now, I like to look at points that are real close to the line that are on each end. So I'm going to grab this point here, and we're going to say it's right here in the crosshairs, because real close to that order pair there. That's going to be 6 comma 6. So you know what to do, guys. Anytime you're given 2 points and you're told to write a linear equation, you know to use this model right here. Okay, so there it is. So with that in mind, now I've got to first of all find the slope because I need the slope right here. Alright, so my slope would be y minus y, that's negative 4 and 6, so negative 4, negative minus 6. X minus x, that's negative 4 and 6. Negative 4 minus 6, that's negative 10 over negative 10, which would be a positive 1. So my slope is positive 1, so where the m is, I will put a 1. Now it doesn't matter which ordered pair you pick, I'm going to use this one here because there's no negative numbers. So y minus a y value, my y value is 6. X minus an x value, my x value is 6. So now we're going to take the 1 and multiply it through. 1 times x is x. 1 times negative 6 is negative 6. Bring the negative 6 over and make it a positive 6. These cancel out, leaving you with y equals x. And there we go. Okay, guys, I hope this review sheet's been a help to you. I've tried to give